Implementation of BFS algorithm in C language. This header file is included for input-output operations like printf and scanf. This header is included for dynamic memory allocation functions like malloc or free, not directly used in this code but can be useful for the future expansion. This defines the maximum number of vertices that the graph can have. This is the constant value used to size the adjacency matrix and the queue. A queue is defined using a structure queue which holds items max vertices. This is an array to store the items, that is nodes, in the queue. The maximum number of elements is max vertices. Front and rear. These variables are used to keep the track of front and rear positions of the queue, indicating where elements should be dequeued from and queue to. Let's initialize the queue. The function initQueue initializes the queue by setting the front and rear to -1, which indicates that the queue is initially empty. Now check if the queue is empty. The function isEmpty returns 1, that is true if the queue is empty, that is front is equal to -1, and 0, that is false otherwise. This helps in controlling the loop when processing the queue. Now perform enqueue operation. The function enqueue adds an element, that is value, to the queue. If the queue is full, that is rear is equal to max vertices -1, it prints an error message. If the queue is empty, that is front is equal to -1, it sets front is equal to 0 to initialize the front pointer. The rear plus plus increments the rear pointer and the value is added to the position rear in the same items array. Now let's perform dequeue operation. The function dequeue removes and returns an element from the queue. If the queue is empty, it prints a message and returns -1. Otherwise, it stores the item at the front position in item, increments the front pointer and checks if the queue has become empty, that is front is greater than rear, in which case it resets both pointers front and rear to -1. The dequeued item is returned. Now write the function to perform the BFS traversal. First, queue initialization. The function BFS initializes a queue and visited array to track which nodes have been visited. Next, starting node. The starting node is enqueued and its corresponding entry in the visited array is set to 1. The while loop continues until the queue is empty. In each iteration, a node is dequeued from the queue and its value is printed, that is processed. The function checks all the neighboring nodes of the dequeued node by iterating over the adjacency matrix. If neighbor has not been visited, it is enqueued and marked as visited. This process continues until all reachable nodes are visited. Now write the main function. First, graph initialization. Graph max vertices matrix is initialized to store the adjacency matrix where graph of I and j is equal to 1. Indicates an edge from vertex I to vertex j for directed graphs. Input. The number of vertices and the edges are input by user. Then the user is prompted to input the edges which are used to populate the adjacency matrix. BFS call. The BFS function is called to perform the BFS traversal starting from vertex 0. The graph, the start vertex 0 and the number of vertices are passed as arguments. Here is a sample output of the program. First enter the number of vertices 6. Enter the number of edges 7. Enter edge, start and end vertices. Give the inputs after performing the BFS traversal starting from node 0, 1, 2, 3, 4, 5. Here, the program uses a queue to implement the breadth-first search algorithm, which explores a graph layer by layer, visiting all neighbors of the node before moving to the next level. The queue keeps the track of node to be visited and visited array ensures each node processed by only once.